Right. I welcome you today to this discussion I want to make. It's about the tutorial that I gave you. This particular tutorial requires you to understand the relationships between correlation, covariance, and regression. So you were given a hypothetical example. I think I actually took it from a real data set of the relationship of about 4 variables. There was demand for beer, quantity demanded for beer, there was price of beer, price of wine, and income. And so to save me time, I've already done these calculations which you should have done, so that I'll just start exactly where you need to do the answering of the questions. So the first question says that you are supposed to calculate the covariance of beer, of quantity demanded for beer and price of beer, and in the second instance covariance of the quantity demanded of beer and price of beer, and in the last instance the quantity demanded of beer and income. So what you will recall, QB representing our quantity of beer, PB price of beer, PW price of wine, I representing income. What you recall is that the covariance of QB and PB is just equal to the summation of QB minus QB bar PB minus PB bar everything over n minus 1. Now from these various summations you have done, you will see that the particular term you are interested in is this one here. This one. Okay? That's the number you are interested in. So that means we want to take minus 43.498 and we divide that. Our sample size was n equal to 17. So that's 17 minus 1. The answer you will get here should be minus 2.72. Now, it is clear from this number that price of beer and quantity demanded for beer have a negative linear association. Judging by the sign there, then you are required to explain if this covariance agrees with theory. Of course it does. It confirms the law of demand. You remember that the law of demand postulates that there is a negative relationship between quantity demanded and price. So for that one we are done. I think this is question 1A. Then B requires you to do the same for wine. So covariance of quantity demanded for beer, price of wine, is the sum of QB, PW bar over n minus 1. The relevant summation you are interested in is this one. And so that's minus 45.957 over 17 minus 1. The answer you will get is minus 2.87 minus 2.87. Now, probably least expected, one would have expected that there will be a positive linear association, but what we get here is that there is a negative linear association. Now, does that conform to theory? Well, we wouldn't know, but this negative sign would suggest, the negative sign suggests beer and wine to be complementary. To be complementary goods. You must record this from Economics 1. Then you go to your C, which requires you to compute the covariance of QB and your income. And this must be the sum of QB minus QB bar, income minus income bar, over n minus 1. The relevant summation you are interested in is this one, which is minus 208,015.982, and you are dividing that by 17 minus 1. The answer you should get is minus 13,001.00. Now, what you observe here is that there is a negative linear association between demand for beer and income. Now, from your microeconomic theory, you will notice that whenever demand has a negative relationship with income, it means that a particular good we are talking about is an inferior good. So in this case, beer is an inferior good. It's most likely an inferior good because of this. Right, so that's how you would approach the first part of the question. Then let's do the second part of the question. Now, the second part of the question requires you to compute the correlation coefficient. So you are required to calculate the correlation coefficient again between QB and PB, QB and PW, QB and I. So what we know is that the correlation of X, what am I doing? QB and PB is just the same as the covariance of QB, PB, everything over standard deviation of QB, standard deviation of PB. That's what you need. We have calculated our covariance. Where is it now? It was minus 2.72. The computer is restarting there. It was minus 2.72. That was the covariance. So what we want are the standard deviations of this and the standard deviation of that. The standard deviation of the price of beer is 0.410, and the standard deviation of the quantity demanded for beer is 8.04. So it's 8.084 by 0.410. This should give us a correlation coefficient of minus 0.82. Notice that the number we got lies in between minus 1 and 1, which is what we expect. It preserves the sign of the relationship that we got from our covariance analysis. But this, of course, tells us that there is a reliable linear association between price of beer and quantity demanded beer. Then you can do the same, and of course it agrees with the law of demand anyway. So you can do the same PW, which is the covariance of QB PW over SD QB SD PW. Now, the covariance was minus 2.87, and we are to divide this by 8.084 by the standard deviation of PW is 0.516. You should be able to get something like minus 0.69. It again preserves the negative sign we found in the covariance, and it is a number lying between minus 1 and 1, which also shows that there is a moderately strong, moderately reliable linear association, negative linear association between the two variables. And lastly, correlation of QB and income, which is the covariance of QB income over SD QB by SD income. This, of course, I think the covariance was minus 13,001, and we are dividing that by what's the standard deviation of income? It's 2497.743 by 8.084. The answer you will get here is minus 0.64. Again, a moderately strong, it's in the mid-range, a moderately strong, moderately reliable negative linear association between the two variables. So that's about question A and B. Then the next question, which is number 3, requires you to either use the covariance or the correlation and any other information you have in the question to calculate the parameters, or to estimate the parameters in the regression equal to B0 plus B1 PB plus a disturbance term, and you do the same B0 plus B1 PW plus a disturbance term QB B0 plus B1 I plus a disturbance term. So you are to estimate these various coefficients, the intercept and the slope coefficient, using only information you have about correlation or covariance plus any other information you need to be able to do that manipulation. So I will use both methods for the first example, then For the rest of the examples or for the rest of the questions, I'll just use the correlation coefficient. So for your 3a, what we know is that beta 1 is equal to the covariance of QB PB over the variance of PB. That's what essentially it is. That is, after all the manipulations, you remember that we carried out. So the covariance of PB and QB, we calculated it somewhere. Okay, it was minus 2.72. And you are dividing this with the variance of PB, which is 0.168. This one here. The answer you should get from all this should be minus 16.168. Okay? Now let's try to calculate that using a different method, which is the correlation one. That's correlation of QB, PB by standard deviation of QB over standard deviation of PB. This therefore leads us to the following. We got the correlation coefficient for this. It was minus 0.82. If I'm not mistaken, 0.82. We are multiplying it by the standard deviation, which is the square root of this number, and the standard deviation of this, that's square root of that number. That should be 8.084 over 0.410. The answer you should get here, knowing that there will be some rounding off errors, I think it will be minus 16.190 something because of rounding off, but you can see that for all practical purposes it is the same coefficient. Okay, so you can use any one of these two methods to get your estimate for B1. So how do we get B naught? B naught is equal to QB bar minus B1, which we have already calculated, and PB bar. So you only need to know the means for these two. I don't remember what those means were, but we can easily calculate them. So here, I think it was 59 or 57. So here it's 59.947 less, let's use this one which is more accurate, less 16.168, which we just calculated, multiplied by the mean of our PB, which is multiplied by 2.612. The answer you will get is 17.716. I was using my phone to calculate these things, so I'm assuming that I never made a mistake in calculating using my phone. So, in other words, we are actually saying that the demand function is equal to 17.716 minus 16.168 PB. That's the demand function for beer, right? Then you are also required, I think at this stage you are not required to interpret this, it's just calculating them. So that's how you get a first. I think you can replicate the rest following this approach, but for the avoidance of doubt, I can do the other two. Therefore, B1 in B, we are now in part B. This is for A, this is B, this is C. In part B now is equal to a correlation of QB PW by SD QB over SD PW. The correlation was minus 0.69, and we are multiplying that by this one is 8.084. The other one is 0.516. You should be able to get something like minus 10.81. And replicating our approach, which is your QB minus your B1 PW bar, you should be able to get something like 31.711. I have not entered the numbers, you know them, and this one is that number we just estimated. And for 3C, your B1 would be correlation of QB income, standard deviation of QB, standard deviation of income, and this should be minus 0.64 by 8.084. That should be divided by the standard deviation of that one is 2497.743. This must give you something like minus 0.02. Okay? And you should get your B0 being equal to 942, something like that, yeah. Is it point? Okay, point 59.942. So these are the calculations you are required to carry out. Then, of course, the next thing is you are asked to interpret the slope coefficients. I will interpret one and then leave the rest for you to do on your own. Now, in question A, we got our QB as 17.716 minus 16.168 PB. In the other one, we got QB, I will do the income one, was equal to 59.942 minus 0.002 income, right? Now, what does this number mean? Now, remember that your original regression is QB is equal to B0 plus B1 PB plus a random error. If we take expectations of both sides, that is given our price of B, and we take expectations, we apply our expectations, Now, by the assumptions of the classical linear regression model, the expected value of a random error term is 0, so this thing vanishes because of that. So we are left with expected value of QB given PB is equal to expected value of a constant, remains a constant, and this will be P1, because this number we know it from the data set, so the expected value of PB is also PB. Essentially, this is what we estimated. Now, expected value, or the conditional, this number here actually tells us that this relationship here is the conditional mean of QB. Therefore, it means when we interpret the coefficient, it is telling us the effect of PB on QB, and it tells us by how much our QB, our quantity demanded, changes on average as a result of a change in PB. So therefore it means that we can interpret it as follows: a 1 rand increase in price of beer leads to a 16.168 units. We don't know in what units beer is measured, so we just use the word units. Units decrease in quantity demanded for beer on average. This is a very important phrase. If it is missing in the interpretation, then the interpretation is wrong. So you must mention that this is on average, okay? If we were using more than 2 explanatory variables, then in addition of on average, we would also have ceteris paribus, that is other things being equal. But because this is just a bivariate regression, on average is the most important thing to mention there. Now, if we look at the demand for beer, which we modeled using our 942 minus 0.02 income. So it means that if income increases by 1 rand, demand for beer would decrease by 0.002 units. Now this particular number is nearly 0, right? Now because it is nearly 0, what it actually tells you then is that, you remember we had said that this good beer is an inferior good. That's what we said because of the minus sign on the coefficient of income. But if you look at the size of the coefficient, which is nearly 0, which means that demand for beer does not, for all practical purposes, respond to changes in income, then beer seems to be a basic good. A basic good in a sense. I'm just judging by the size of the coefficient of income, but for you to be able to clearly say it is a basic good, you need to calculate the income elasticity of demand. And if you find that the income elasticity of demand is more or less, it's just about 0.00 something, then you can say it is a basic good. But we are certain that it's an inferior good because of the minus sign there. So that's how you use your econometrics to test your economic theories. We could have, for example, tested some hypotheses, but because we are still doing introductory parts, we are not testing any hypothesis yet. It's just learning how to calculate the coefficients and how to interpret them, okay? So then what would this number mean? So this is the average value of, or the average level of beer demand when income is 0. And this is the average quantity demanded for beer when price of beer is 0. That is, if someone says, here you are going to get beer for free, if you like, come and you have some, we would expect to see about 17.716 units of beer taken by people when price is 0. So I will stop here until we meet again.